Okay. Well, for people who are joining this live stream, this is a design discussion about geometry functionality in Wolfram Language. And it's one of a series of discussions. It's been a while since we had the last one on this particular topic. Okay, so should I start from this notebook?
Yeah, maybe as a little bit of introduction. So we made actually quite a few progress, I think, as well on the algorithmic, as well on the design side. Some things have changed quite a bit based on really trying many examples and having various people trying it out, how it works.
Okay. So should I load a bunch of stuff, or is this...
Load these two things, evaluate these two code cells at the top.
Is that going to... Okay, fine.
It's local.
Okay.
Not everything will work. There's a set of working examples at the bottom.
Okay. Why don't we just go to something big that works, so I just get some idea of what's going on? Or tell me how to get started.
The very first example should work. So if you click open that represent a scene, or actually the specified coordinates, the one below that. Right. So if you shift enter that, it should draw it again.
Okay. All right. So this is, so let me just try to understand this. This is a triangle with explicit coordinates, ABC. How does it manage to label this? I don't understand. How does it know how to label any of this stuff? Oh, I see. This is essentially like a geometric block where it's saying, this is the payload, and here are a bunch of values. Those are points, and that's a scalar value. Is that correct?
Yep.
Right. Okay,
so here, this presumably, I don't know why we have a semicolon at the end, because I want to see what it does.
It does nothing.
Okay.
So this,
how do I visualize that?
Right. So this represents the scene. If you use find geometric scene instance, Ian, is that the new name?
Yes.
All right.
That is an incredibly long name.
Well,
find geometric scene instance.
So that will automatically find coordinates and values that work for that. And so
okay, but I don't understand. Some of these things are propositions and some of them are objects.
Exactly.
The objects basically have an implicit, there exists around to make it a proposition.
Okay, so there exists a triangle,
right,
such that the predicate circle through this is true and O is the midpoint of that line.
Right.
And so why would I draw? So when I draw a predicate, I'm drawing an instance of that predicate being true, but why? I mean, I
don't view circle through as a predicate. Use it as another primitive with a side condition attached.
I'm not quite.
A circle through is still a circle.
It sounds like a constructor, Stephen.
Right.
You know, because that can always be done, presumably.
Oh, I see what you're saying. So a circle through. So in principle, we could have that be part of the standard computational geometry world, just like triangle is a part of the,
for concrete ABC, it would evaluate to a real circle.
So it'd be like SSS triangle.
Right. Excellent.
Right.
That makes perfect sense.
Right, but
there's a number of these, like circumcircle.
Yeah, I get it. This is great. I mean, so we've also talked about things like line through.
Right. We still use that.
What's that?
I said we still in this project we're still using line through pretty heavily.
As opposed to doing what?
Well, so as opposed to for the existing line does not specify that it has to be a straight line segment. So we use line through if we want, say, points A, B, C, D to all be on a straight line in that order.
I see.
What does that even exist unless they're collinear?
No, that's the whole point. But that is making the statement that they are collinear, Roger.
Right. So in this project, since we're starting out with these abstract symbolic points that don't have coordinates attached, we can say circle through, A, B, C, D. In general, 4 points don't necessarily lie in a circle, but if we say circle through of A, B, C, D inside of geometric scene, then we're saying these points are going to lie in a circle, and we're going to draw that circle.
Right.
So I want to clarify that line through is like, it will return a line in a concrete case. And it's
a line or infinite
line? A line.
A straight line.
We also have
a segment.
Correct.
A line which is
correct
in the end.
Okay.
And we also have infinite line through for the infinite line case. Mm-hmm. And it's not so much that it is a proposition, but it's that our solvers are solving for points that satisfy all the constraints, but then also that all of the regions are valid. And line through is only a valid region if they're collinear.
Okay, so that thing is perpendicular?
Yeah.
This code will not work here.
So, but what I would normally do is I would say find geometric scene instance, correct?
Right. So if you wanted those explicit coordinates you see below, you could do find geometric coordinates on that scene, and it would just return coordinates like the one you see.
Okay, but if I take out the coordinates here, will find geometric scene instance do something useful here or not?
Yes, it fills in the coordinates. And
I get that. But so if I take out the coordinate blocks here,
you'll have to take out the conjectures at the bottom. You would have to
so
take out
I
for
just
this to work.
taking this. Is that correct?
So this example has 3 arguments. The first one's a list of rules. The second one's list of hypotheses. The last argument is list of conjectures.
Okay.
That list of conjectures is what we don't have implemented yet.
Okay,
Right.
so fine. So I understand. So what you're saying is this is like find equational proof in the sense that it has first a set of axioms, effectively, which are these things here, and then a set of propositions.
Mm-hmm.
Where the set of propositions potentially gets subdivided in 2 groups, one that we find and one that the user gives.
Okay. So I understand. So this is all right. What do I look at next? I think I understand this thing here.
Right. So Ian, maybe go over kind of what this first section is in terms of talking about our various design issues.
So all the cells from the.
So Stephen, you asked what does find geometric scene instance do that's useful? If you can have just list A, B, C, O without the rules. And what find geometric scene instance is supposed to do is to turn those into rules. And if there are rules, then that's supposed to auto format as
okay. So fine. So then what I would do here is I would take this, I would just say ABCO here.
Yeah.
Okay. And then I would say, so that just becomes, that's just a symbolic thing.
right.
And then I say find, then I do that whole find geometric scene instance there. Wowee. Okay, let me just. Okay, so triangle ABC, yes. Why does it choose that ordering of the triangle?
Let's come back to the subject later. That's a whole section.
What's that? There's a whole what?
There's a whole section in the notebook on the subject.
Well, so it.
Roger, did you choose a definite ordering for your triangles? You must have.
They are always counterclockwise.
Here, the scene jar, I think it tends to go counterclockwise, but it doesn't have to be counterclockwise.
Okay, all right, okay.
No, I mean a user can specify whatever order they want.
Right. If you actually, if you put in, if you wrap clockwise around triangle, it should come up clockwise.
Okay.
Charles won't like that because technically polygons on oriented points are.
Okay. Let's not worry about that yet.
Yeah.
Okay. So this is very, very cool. So this is then making. This is I get it. So this is a rendering of that particular scene statement.
Right.
Okay.
And we can from this rendering or directly, you can get coordinates to put in, inside
if I
geometric
find
scene.
geometric coordinates,
Yes.
then I will get a list of rules, presumably.
You have to put in the scene, not the graphics.
Because like in the future, the what you get out is just a format version. It is still a geometric scene, but it's not yet implemented.
I see. So in the future, this will simply be in other words, there are two things which are both useful, namely the symbolic representation and the actual visual representation.
Exactly.
And so, one could imagine even something like a show that,
no, we were more thinking kind of like, as the first little graph showed, geometric scene is the total centerpiece of it. And as much as possible, the object is a geometric scene that formats, like a region nicely formats. But then you can apply string arguments like graphics or other things to get the things out that you might want.
Yeah, but still, this is a useful thing to be able to see here.
Yeah, that's what I'm saying. No,
right. No, I understand. But by default, would that format as a picture, or would that format by default as that symbolic representation?
It formats as a picture when you have coordinates specified.
I see.
It doesn't search them automatically.
What's that?
It doesn't search the coordinates automatically. You must say search.
That's perfect. Yes, that sounds good. Okay, let me understand this. Okay, so what is this creature?
So basically, in this particular scene, you did not specify a radius for the circle. So for circle 3, you have the 3 points on the circle and the center. So it comes up with its own unique name for the radius. And right now it's kind of ugly for debugging purposes. But the graphics primitives that it generates requires a radius. So it just comes up with this name for the radius out of whole cloth, and then finds a value for it.
But so that value could be any value from, it could be 10 megaparsecs or something.
No, it's constrained because of A and C.
No, but it's constrained once you've got an A and C. But the problem is that this statement here could be a triangle, apart from problems of, space-time curvature. It could be a triangle, rendered across the galaxy.
No, but it says circle through ABC.
I know that, but ABC, the point that I'm making is ABC here, right, are just abstract points. They could be on the other side of the galaxy.
Oh, that's what you mean. Sure, absolutely.
Right. So there's nothing that gives a scale size here.
No.
Arguably, fine geometric coordinates should be given a bounding box in which the thing should operate.
Optionally.
Right.
I agree. I'll make a note of that.
One issue is if the user wants to put in explicit coordinates, we allow that. So if they want to be,
I get it. Right. That makes perfect sense. What I'm saying is nothing sets the scale size from a micron to a million miles.
But there are only two possibilities. Either basically the user sets at least 2 points so that we have a natural scale, or we search in the scale of 10 to the 0.
No, I agree. The default should be a scale of order 1.
Yeah.
I agree completely. But I think it might be useful to imagine, essentially a plot range-like thing that says, okay, make this be something that as much as possible fills the -1 to 1 box or something. Minor point.
Right.
I think that might be useful for, I don't know yet, but okay, let me try to understand the generated object here. Because this is, like when we say generate conditions or something in an integral, right. It's the same type of.
No, it's more like generated parameters.
Okay.
The condition is typically expressed in user variables.
Right. Fair enough. But so what's an example of a generated parameter? How do we do that normally?
We say what the head of the object is.
Why on earth? I don't understand. It doesn't even mention generated parameters in these basic examples.
Because it's not basic.
I think that's crazy. I don't understand at all.
farther down is obviously.
I know, but we should, these examples, I think that's a Roger issue. I mean, these examples where the basic examples on the page for generated parameters should surely have something about generated parameters in the basic examples.
No, but there is obviously a generated parameter. It's just that it uses the default option setting.
I know that, but so the very first thing here should be name the generated parameter alpha, I think. After this, you show this one and then you say name it alpha.
I agree.
Okay, so here we're just giving a head and it's giving numbers. So now what is the form of generated parameter in this case?
We should probably do the same here.
Okay.
Right.
Where it's simply called generated parameters, and then, well, does it want to be a named parameter where you know that it's a radius, or does it just want to be a generated parameter, you know, C sub 1 or something?
If you wanted to name it, you should have named it from the beginning.
I agree. I only have it this way because I'm the one who wrote the code, and it's a lot easier to debug when it's very explicit.
Yeah. I mean, I think there's an argument that a generated parameter, like a missing, should be able to have certain metadata in it.
This is an argument. I do agree.
And maybe we want even a notion of, you know, generated parameter. I don't know if this makes sense, that formats in a certain way, but that, you know, contains its metadata. And even generated parameters could conceivably default to some kind of generated parameter thing. I think that would be nice to be able to take the thing apart and see something about where it came from.
So do you mean something like trying to differentiate if something is a coordinate or radius or a length or an angle?
Yeah, right. So, I mean, just like missing would give, you know, not available or something like that. It would just say generated parameter radius, comma 1 or something. Now, I don't know about the comma 1 because I would even argue that we might be better off with UUIDs because that way we you know, there's no possibility of a
Or we are better off with
No. I mean, in these other if you're going to overload it, here, if it's hidden, I think UUIDs are fine. But could you imagine your differential equation coming up with C4ECD6EC6-50B?
No. Okay, Roger, you don't need to say it. No, I mean, my question is it important that these things be distinct?
Only within a scene, basically.
If you have two circles, you need to know which radius belongs to which circle.
All right, so there could be two possibilities. One is,
do you ever take it as input and combine two of them where there's going to be name clashes?
Not right now.
What's that?
There are de facto no exercise in high school books where you make first two constructions and then somehow glue them non-trivial together.
Okay, well, I'm not counting that as definitive, but I do think that in the case of differential equations, the fact that this is C sub 1 and there's another C sub 1 could get you in trouble, and you'd be better off. I mean, the issue, Roger.
Yes, but Stephen, there's also a danger. Well, if you have a different differential equation, I see a point. But if it's the same differential equation, then you get different C's that's also not good.
Yeah. So actually, these solvers work recursively, all of them. And so they might, in fact, get some of that as input, and they manage that. That's what I'm saying.
Okay, but what about
they have to make sure that a new parameter is distinct from the existing ones.
Okay, let me make a crazy suggestion. What if the thing is a hash of the differential equation? If the parameter is somehow, I mean, maybe you can even just give the differential equation there as part of the generated parameter so that it knows that this is, you know, for that particular differential equation.
But then you would first have to bring them in normal form.
I understand. It's undecidable probably whether two differential equations are equivalent.
I am not sure what you're talking about. The problem is that the different parameters need to be different.
I understand that, Roger. I understand. What I'm saying is...
And I don't know what hash has to do with that.
Okay, so what I'm saying is...
Hash is maybe a technique to decide whether two things are easy or the same.
No, you're not understanding. What I'm saying is you solve a particular differential equation. It generates a C1 and a C2.
Yes.
Okay? You solve the same differential equation again. Generates a C1 and a C2. You are saying you want those C1 and C2 to be the same every time you solve the same differential equation. But if you solve a different differential equation, the constants you want for that different solution should presumably be different. It would be nice if they were different variables. They're different symbolic constructs.
Actually, I actually disagree with this,
Okay.
because, like, the simple example, you solve some complicated differential equation recursively through some series expansion. At each order, like secular, you want to get secular terms out of some celestial mechanics problem. So you over and over solve more complicated differential equation. At each point, you have to fit the parameter C, the C's. So you can just easily pattern match, give me all C's, and then I figure them out. So you have one more step figuring out what are actually the three parameters.
Okay. Well, listen, I know. Let's keep going with the geometry thing. I just want to, come back to this question of.
But here's a scenario that's come up with respect to potential use cases. I don't think it's fully sorted out, but for instance, if you have something that has parameter in it, like that first example you on your right side there, or second one, let's say you want to plot it. Now you have parameters.
Yes.
So you want to set them to values. Should that be automatable in some sense? And what are nice sort of default values?
Right.
Clearly, in this case, 0 it might be a good default value. If it's multiplicative, that's disastrous. Really,
No, that's a very interesting point, and that's very similar to the find geometric scene instance.
Right.
I mean, it's basically a find parameter instance. Is that a fair statement? I mean, is it obvious from the output? If you say find parameter instance, you want a generic values of the parameters somehow. Like, for example, here, if you say find parameter instance, you can read the fact that C sub 1 is an integer.
Right. I mean, there's a function called find instance.
Yeah, which I could presumably run on this thing. So I
Right.
could just take this.
That changed the head to be find instance. It will give you an instance.
No, I understand that. But if I
No, back up. Change
Why?
reduce to find instance.
Why can't I just do this?
Well, you can, but it's okay. Great. But run find instance to begin with. Don't make your life so damn complicated.
No, but that will give me an instance of X. I was trying to.
Isn't that what you wanted?
No, I was trying to get an instance of C sub 1.
I think Adam is saying something, but we have a problem hearing him.
Yes. Adam,
so you need to specify all the variables that are there. So you need to specify C1 and X, and you will get an instance for both.
Okay. Nice. So that's solving. So that is in fact doing what we talked about. What Roger was saying we might like to do, which is to be able to plot this thing, for example.
Right, but your life would be even easier if you started with find instance. So I'm saying you just made your life more complicated.
Well, fair enough, but I mean, just a minute. So you're saying if I just say that, fine.
There you go.
Yeah. Okay. Well, okay, depending on what I want. Okay, let's keep going here. Okay, I don't know what happened with this.
So this isn't implemented yet. So basically, a lot of this first section are kind of parallel proposals for how we should format geometric scenes. So you shouldn't really evaluate anything until we get to the very end of the notebook.
Okay. All right. So
I had faked output for that got broken somehow, but the idea was, since each point had a list of several coordinates for it, that you would get like a tab view. You could look at several.
I think that's funky.
Pictures.
I reserve judgment on whether that makes any sense.
Fair enough.
I mean, I think the listability, first of all, I wouldn't necessarily do the listability that way round. I mean, what would you do if there were an unequal number of coordinate choices for each point?
Fail spectacularly.
Yeah, but I mean, why set it up that way? Because you could have something where you naturally have it so that you can, I mean, if you were to generate this, it would be more natural, I would think, to generate it as the code that would generate multiple instances would be more likely to generate a list. A goes to blah, B goes to blah, C goes to blah, multiple times.
So the transposed version.
Yes, that's what I'm saying.
This makes sense.
To make more sense to me.
Yeah.
Now, I assume that I can replace these symbols by strings and nothing will break.
Correct.
Okay. All right. Let's take a look at this guy. Okay. So this is a bit fancier.
Now we come in some more the philosophical points.
Right.
Okay.
So the question here, you pointed out that we were mixing primitives and propositions.
Yes.
So one suggestion is, well, we should split them up into two different arguments, and this section is discussing the pros and cons of that.
Okay. But Michael was saying there's an existential, thing here.
You can view that as the statement that is a valid triangle, or that is a valid circle through.
Okay. All right. All right. So the question is, what are you asking? So what the heck is this? I see. That's a rendering primitive. So you could say style of circle through.
That's one of the things to be discussed.
Right. Another kind of off-the-wall thing is continuing that so that if you say you wanted a regular polygon, you could do list regular comma polygon of ABC.
So the philosophical question here is, do we follow the graphics style directive paradigm, or do we consider it more like the first argument of solve and reduce, where it has to be more propositional?
Well, I think that a styled circle through makes sense to me. I mean,
the alternative is following the region and graph highlighting one, having an option that says who is to be styled and how.
I hate down a little bit.
I hate that. I mean, I think that's, look, okay, several comments here. First of all, you think that this is a pure...
Michael, graph and meshes and so on allow both. They can deal with wrappers, and they can deal with options that you can control big chunks of things.
Okay, fair enough. Yeah, that sounds sensible. But let me make a comment here. Okay, you think that triangle has a visual, graphical, representation, but perpendicular doesn't. I would argue it does too, because on the plot you might draw one of those little perpendiculary, marks.
No, they both have a graphical representation, but the triangle is a region. It's a set of points in the plane, where perpendicular is not a set of points. Even if it might have some kind of label-like thing.
I understand. So in formal logic, right, there's, when you start setting up a language for a logic, so to speak, there are typically these different kinds of objects which are identified there. And I'm not sure, I'm not sure how sensible it is to do that ultimately. But let's come back. Okay, so the question, personally, I would say mixing these makes sense to me, with the assumption that this is really that the full form of this exists FPA triangle. Is that right? I mean, is that what you imagine that the...
Yeah, something like this.
Right, because we're circle through with 4 points on the circle, you have to make that assumption.
I think it's more like region Q than it is like exists.
Really?
Yeah, subtle differences, I would say.
Because exists FPA, that doesn't change the fact that triangle itself isn't
a predicate.
Boolean, right? So really what we're saying is we're trying to find an FP and A such that all the graphics primitives that show up are valid.
Okay, so
triangle that's not very strong, but circle through that's pretty strong.
Exists FPA region Q triangle.
With the exception that, that won't be region Q because it's not concrete, but essentially.
Well, fair enough. But I mean, yeah, the issue is that is not a very graphically, that exists. Okay, I mean, this is, boy, I get into these ridiculous philosophical things so quickly. I mean, the question of whether, whether existence can be painted, so to speak, by which I mean,
it reminds me of sort of equals, okay? A equals B doesn't say false, right? It's not a Q function.
Right.
You know, and it sort of asserts it.
Yeah, but triangle, what the heck does triangle do?
But I feel like keeping in mind the audience for this, if we want to do this for high school students, we cannot litter this with existential things.
Of course. But the issue is, what is the full representation that we're imagining that this has?
I think what you have there is a fine way to conceptualize
Imagine.
it.
Okay.
But I don't
fine.
think it.
But I mean, so my question is, there are predicates. Okay. The issue is sort of, there's certain aspects to this which are picturable and others that are not.
Mm-hmm.
We got a bunch of background noise. It would be nice to cut that out.
I think it's then, and it's some kind of static.
Okay. Okay, but do you understand my point that there are some? I'm
Yes.
just thinking it's sort of in the mind of the computer. There are certain things that can be visualized and others that, you know, when you say triangle, could somebody put themselves on mute? That whoever has a weird connection to this. Yeah, now that noise went away. Thank you. Okay, but let's ignore this. Is this evaluatable? This thing here?
No, this is not, because it has the argument for conjectures.
So if I remove the conjectures, can I evaluate it?
We don't support the graphics primitives or the red yet. So if you take out
So
the
if I remove the red, can I evaluate? Oh, look at that! Yes, you do. That's magnificent.
Really?
No, that's the faked output.
Oh,
that was already
yeah.
Okay.
I was gonna say I don't remember implementing this at all. You'd have to take you have to take the braces off the circle through.
Why didn't that work?
Let me take a look. A, B, E.
There's no C in
Right. You didn't list all of the.
Okay.
No,
Ooh, magnificent. I mean, it's a bit degenerate. Why is it so degenerate?
Sometimes when the scenes have circles, the points tend to clump.
So let's figure out how to prevent that happening. Right? I mean,
Yeah.
in other words, we need to have good aesthetics for these things. Make sense?
Right.
What's the right heuristic for
We
doing
we discussed this in great detail. But there are maybe some limits with the current constraint solvers we have available.
Okay. This is very nice. I mean, it's kind of slow. What's it doing? How is the constraint solution working?
So basically, we format a geometric scene as a constrained optimization problem, where the value of the objective function when we get a good scene should be 0. So then we throw that into find minimum using IPOpt, and it works better than I would expect at solving for coordinates for the points and values for the quantities.
Okay.
So basically,
so in the end, I mean, well, Roger, can you comment on that? I mean, what is the form of optimization that, I mean, is the...
I need to see the underlying problems. Given that statement, I don't know what problems you're feeding.
We have this discussion in reasonable length with Danny, Nina, Rob Knapp, so nobody has a better idea what to do.
Okay. All right. So then the only question is how to get something where there's a better... I mean, like this one is kind of iffy because it looks...
Well, one thing one could imagine doing is that, let's say that if you run an optimization, you find something, but clearly you know how you can modify and iterate your way in that scene to, something that's more aesthetic. If something gets more...
I've got a different suggestion. What if there was an additional constraint function, which was an aesthetic constraint function that, for example, was like a repulsion between.
Yes, we try. We do this.
Right.
That's already done.
Well, so there are bits in the code that try to guarantee that the points aren't directly on top of each other, although a lot of times they're very near each other.
Okay, but so then you need to change the parameter. I mean, because you don't want them to
Right.
be that close if you can avoid it.
Right. So, just one potential problem is we do allow the user to put in, if they want to explicitly define where they want certain points to be, they can put in the coordinates directly. So if they specify that the coordinates have to be close to each other, then that would come into conflict with some
We can deal with this. We can deal with
Yeah,
this.
that doesn't seem too bad. I mean, okay, but what I'm saying is you should also have, and this, I don't know, can Charles speak to how this relates to the graph drawing problem? I mean, like this situation here is not good, right? So you want something where the cost function says, I don't like that, when that line goes too close to the point. Is Charles with us?
Yes, I'm here.
Can you comment on how this relates to the graph drawing problem?
Well, on top of my head, I see that maybe, if you get already one solution from it, you can essentially, like we do in graph, essentially try to, I will not say re-optimize it, but, find a better solution by, using the initial solution as constraint. It's kind of what we do for spring electrical type layout.
By the way, it is now the case that graphs can have pinned vertices. Is that true?
Not yet. Plan for 12.
Oh. Well, one of these days you're going to tell me that's actually done. Wonderful. Okay. All right. But so you're saying that you have an iterative technique that. So Michael, do you understand that iterative technique?
I don't think that's possible here because you don't know whom you can keep.
What do you mean by that?
Like to do this iteratively. Everything is nicely fulfilled right now. Yeah,
Yep.
At least all of the explicit ones. So it's not totally clear how to start with this configuration and get a better one.
Well, what about so there is a derivative. There's a presumably. I see. Is it the case? Okay. This is a geometry question, which I should know the answer to. Given a configuration that solves these constraints, is there a connected surface of configurations that also solve the constraints?
Sometimes yes, sometimes no. You might have
That's
codimension
the problem
0,
of
1, 2, 3, whatever.
What's that?
You might have codimension 0, 1, 2, 3. Maybe it's a single point. Maybe there's a 3 parameters.
Right. And that's a problem of algebraic geometry. Now, are we in a position to actually compute that for these? This is an algebraic geometry problem. Do we have, from all our fancy cylindrical algebraic decomposition?
In the time scale of hours, yes, not in the time scale of seconds.
Exactly. Yes, it's computable. So the answer is yes, but you wouldn't want to use it.
And there's no way. Okay, and the reason is because those algorithms, even for something like this, get too slow.
I don't think we know. I mean, if one looks more closer at it, usually reducing it to a very general problem that has the advantage, and that has a complete solution. It has the advantage that you have a complete solution, but you won't be happy with. It won't be performant.
Right. No, I understand. So in principle, cylindrical algebraic decomposition would tell one the complete space of possible instances. Is that a true statement?
Yes.
Okay. Do you know even for a simple case what it looks like?
It can get very complicated very quickly.
Okay.
Yeah. Each one of these points, right, is two variables.
Yes.
Right. So
We have some ideas how to work on better things, which we haven't done yet.
But I mean, when I look at this problem, there's a zillion ways to reduce the dimension. I don't know if you I hope you pull some of those tricks.
Yes, we do.
Okay.
By the way, we have a comment on the live stream. Sandra is asking, how does SolidWorks do this? And saying that they can immediately determine if it is, quotes, fully defined, i.e. if there's only one solution. Really? Seems surprising to me.
Well, there's definitely infinitely many solutions if you scale up everything.
There's definitely what?
Infinitely many solutions if you change the scale of your
Yeah. Well,
plane.
but maybe there's a dimensioning thing that doesn't allow that. Roger, can you comment on how CAD systems?
Typically, if you have one solution, it's actually much faster to do things than if you have a lot of free parameters running.
Exactly.
What do you mean by that?
Like if there is a single configuration that fulfills this is typically doable to get it pretty quickly symbolically. But if you have 5 free symbolic parameters in the solution, it's much harder.
I see. All right, let's keep going here.
No, that's one philosophical thing, just to make sure that we're all on the same page. So in this distinction between separating the primitives from the connectives versus inlining them all together, the main reason we want to inline is because it allows much more faithfully to reproduce the narrative of how the exercises are stated in books.
That's fine, but I also think it's a good idea. I think that the notion of being able to decorate these things is useful.
Yes.
To freely decorate, even perpendicular, to freely decorate that with some annotation that says, oh, I want to use this kind of styling to indicate my perpendicular thingy.
Okay, so you would allow the equivalent of red comma line also to be something comma perpendicular.
What? No, I'm saying yes. I'm saying that, but I personally greatly prefer style to the red comma whatever. But you can support both forms. But we should have style. Someone on the live stream is asking what happens if we add this. Is this going to work? See, I put line in here.
Well, so line is already the system symbol that
so I want line through.
Right. If you're going to have a list of points, you want line through. Line is just
okay, fine. Well, parallel. Okay, yeah, this person has suggested. Okay, well, all right. Let's just try the simpler case of just line through FEA, right? Come on. Oh,
that makes the picture worse, right? Because it
this is
down to that intersection point, and we were trying to get the E away from the intersection.
Right.
No,
it's not even.
But it should be able to. What's it doing here? Why did it go off into La La Land?
So
if it doesn't succeed, it sometimes makes more than one try.
Right. So basically, the way
it's spectacular that it worked.
Right.
I mean, it's damn slow, but it worked.
It's very slow. So basically, the way it works with the find minimum call is it does a bunch of find minimum calls until it finds a solution where the objective value returned is basically 0. And if it returns something that's too big, then it does another find minimum call with a new random seeding.
No,
because the conversion depends on the initial conditions. You're not guaranteed to converge to a solution.
Right. So on these
wait. Let's talk about several different things. So one thing is find minimum could end up in an attractor basin that just doesn't have a solution. Is that what you're saying?
Right. And when it does that, it abandons that find minimum call and does a new one with a different randomized seeding.
So just so I understand, I mean, in modern neural net stuff, where we're basically also doing constrained optimization, are the techniques fundamentally, are any of those techniques relevant here?
I don't think so, because the majority of the issue is the constraining.
Yeah. And anytime you solve a very specialized optimization problem, let's say traveling salesman or something, you can develop techniques that are particularly adapted to that problem. And so is the case for neural networks.
Yeah, right.
And the other thing that's special about neural networks, because you basically, a modern iterative solver, unless it's very large scale data, uses second order conditions. But you don't want to compute second derivatives for your neural networks. So they use either no derivatives or first derivatives, mostly first derivatives. And they use a ton of tricks for that particular, thing.
Okay, but so just so I understand here, I'm trying to understand what kind of acceleration techniques we could imagine using. For example, is there any machine learning play that we could make that would allow us to guess? I mean, what's it spending all its time doing? Is it spending all its time iterating towards a solution, or what is it doing?
Yes.
Okay.
I mean, depending on how much time you guys want to spend, I mean, you can write your own optimization solver from the ground up.
Why would that be useful?
Because then you can specialize it to this problem.
Why is that? I mean, but why is this problem that special? Just a bunch of polynomials.
I don't know what the end problem looks for.
Not really.
No.
Like while they could be brought into a bunch of polynomials, that might be already non-trivial work, because you have potentially trig function because of angle constraints. You have square root because of length issues.
Right.
I see.
So we use IP ops for this, and
which is state of the art.
Right, it's state of the art. There are so IP ops currently in Wolfram Language does not accept precision specifications. So this is code that isn't activated now, but we have looked at using other optimization methods that allow these precision specifications.
Okay.
Where we use IPOP to give it the original seeding and then have those run once from that to try to get a desired precision, and those are spectacularly slower than IPOP.
I see. That's not good. Okay. By the way, someone on the live stream is asking, why are these arguments first rather than last? I mean, in other words, why does it look like this rather than looking like solve and integrate? Why does it look like block rather than solve and integrate?
So they were second, and then conjectures are optional, and conjectures went last.
Yeah.
So I don't think we can have them last because of the optional conjectures.
Well, we could deal with that, but
there's also a certain similarity to other constructs like graphics complex.
I agree. I think this is better. Okay, let's keep going here. Well, I wouldn't do it quite this way. Don't we have a different highlighting mechanism? How do you can have a highlighted wrapper in graphs, and you also have some kind of highlighted vertices thing, don't you?
Right, but there's no vertices here.
I understand that. I understand. So we need a different option structure, but I agree with the basic idea that we should both be able to have inline wrappers and overall options. So for instance, one could imagine here some pattern that says highlight every, well, I'm not certain here, but for example, there's going to be styling for every point, right? Like you might want to say all points are styled with, gray instead of blue or something.
Right. So you should be able to have wrappers in that first list of A, B, E, F, P. If I want to highlight the B point.
So those are implicitly geometric point. Is that correct?
Yes.
Okay.
Because then I could define my own label. That's
why. I'm sorry. Why
is special point
any different from triangle?
Can I say that the reason we introduced geometric scene was to eliminate the need for geometric point,
which every single person we showed it hated.
Okay.
Two things. A, it's a long name, and B, there was total confusion about that the geometric point is not a point. Mm-hmm. Because it's the thing inside the point.
So your point here is that, but what if I want to have an angle with a symbolic value? No, I'm sorry, an angle, symbolically, the angle alpha. How do I do that?
Are you saying alpha is the measure of the angle, or you're naming the angle alpha?
What did Euclid do? How did he distinguish between those two things? The measure of the angle versus the name of the angle. I mean, the name of the angle ABC, for example, we understand what that is. Yeah. but that's referring to points. But I remember even in, you know, the sort of manuscripty things, probably not from Euclid's time, but, you know, that there are, you know, there's an alpha, which I guess is the measure of the angle. Yes. How do I do that?
I think you need the 3 points to determine the angle.
So, okay, so I say angle ABC equals alpha. Or something.
Right. There actually, if you scroll to the very end, there's some high school geometry examples with the very,
okay.
Yeah, all very, very end.
Okay, so what am I looking at here?
Keep going.
No, I want to see what else you have here. What is this?
So these are not implemented. They're various other suggestions for kind of the structure.
I mean, they're not other suggestions. This is the fine geometric scene instance that we've been.
Yeah. Okay. So that's what we've just been looking at. Okay. Let me look at fine geometric facts. Can I run this?
No. These are the code actually is implemented, just not for the structure of argument. We're kind of going.
We need to refactor things.
Yeah.
So that's a rather bizarre construct, but that's basically saying, what is the Euclidean distance AC?
Yeah.
Yes.
Right.
That's a very bizarre way to ask that question. I mean, in other words, what you're doing there is you're asking for a proposition, and you're somehow, you know, fishing out of the proposition a value.
Yes.
Right? As opposed to simply asking. I mean, it seems like there are.
Distance.
What's that?
Just so we mean the second argument should just be Euclidean distance.
I would think so. Just like, you know, the question is, okay, the question is again, what is a fact? Could a fact be, I don't think it's really that. I think you want to just say, it's something like geometric evaluate or something. Because what it is it's saying, given this scene, what is the value of this thing?
Correct.
If the question is, you know, is this angle equal to this angle, then the evaluation is, you know, false, for example. So, I mean, I think it's more like, you know, geometric scene evaluate or something.
I kind of disagree. Our synthetic prover allows you to have a pattern, and it will prove all theorems it can find that match that pattern.
Okay,
so
well,
right
that's
now,
a different piece of functionality, it seems to me.
Yeah, let's discuss this on another day.
Okay, but I mean,
but still, the question is, I actually agree with Ian and don't think this is what you said, Stephen. This is more like a flavor of solve.
Yes, I agree.
Like this case, all we're doing is finding Euclidean distance, but you could put something a lot more general in there, just a general pattern to match a general proposition about the scene. That's not necessarily just a measurement.
Fair enough, but I think that there is still a, you know, geometric scene evaluate, which is useful. And whether, and that general pattern that you want there is you want to return all instances. I mean, in a sense, then you want to say, you know, it's more like a geometric scene cases.
What would this do?
Okay, so geometric scene evaluate would take something like this, okay, and would return 5. Okay?
Just 5, okay.
Just 5. Just evaluates the second argument.
So that's a little bit like desolve value.
Yes.
Okay.
Right. And this here, let's say you have a, and then you would say perpendicular, you know, blank, comma, blank. Okay? And that would return all the statements about perpendiculars, about things that are perpendicular in the scene. Am I making sense?
Right. So what you have there for geometric scene cases, that's essentially what I was going for with fine geometric facts.
Exactly. Right.
Same behavior.
Right. I mean, I don't know whether the function is right, you know, what the right function name is. But I'm suggesting that, you know, this is a useful thing. It's like evaluate that, is this true in this scene, for example, rather than trying, you know, is this true, having a thing here and then having it come back as a null list, just say, is it true? You know, compute it given that scene.
I
On our
agree.
live stream, Sander is asking, why do you actually need to give the variables here? Why can it not be like solve, for example, where it assumes variables, where it assumes that every symbolic variable.
Our plan is to allow you to not specify it and fill it in for you, but there are ambiguities that arise in the argument structure.
The vast majority of times we can figure out which things are points. However, since we're allowing users to input specific coordinates if they want to, and maybe symbolic coordinates, so instead of putting in the point P, instead of putting in the point P, you could put in the list P sub X, comma, P sub Y. There are just a couple ambiguities.
All right, well, so let's look at those.
Also, let's note that the one argument form of solve is not documented, even if it works.
Fair enough.
Right.
Okay. All right, let me just take a look here. So what is this? I don't understand. What's this? So
you
this
want to open the cells.
That one there. Okay, but that's that's now saying, but how do I get the actual list of geometric? So can I run this?
I don't believe so.
No.
Okay, so what would I see if I did run it?
You would see the output right below that geometric scene of triangle, like right below where you have your cursor.
Oh, I see. So it's filling in into the geometric scene. It's leaving the geometric scene there, and it is filling in certain conjectures.
That's one of the big points, that the geometric scene is this mega container where everything is nicely together.
Right.
So your point is that to have the conjectures without, or to have the statements, the propositions, whatever, without the scene is kind of stupid.
Yes. Maybe not stupid, but not ideal.
Right. You have to.
No, I would say it's convenient to have them with the scene because you can have it automatically visualized. But like Michael said earlier,
that's a minor point. I mean,
argument to get the conjectures out.
Right.
It's easier to get. So we're thinking the geometric scene of blah 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 of string conjectures could pull that argument out. It's easier to get it out than to put them in.
I mean, the main thing that I think is going to be awkward is the naked symbols here that, you have an X, but somebody gave a value to X, those kinds of weird things.
That would still make a problem because none of the things is held. So it would still seep in.
No, I understand.
Okay.
So, fine. Oh my gosh. Okay. Let's have a quick look through these things. We're not going to get to all of this. What am I looking at here?
These are links to ref pages.
Okay.
Very incomplete ref pages.
This is a little bit what Roger said in the very beginning, that these books use a lot of symbols that it's not clear if we want them as own symbols. It makes it very nice and convenient and short to write them down, the scenes, but they are kind of expressible to things we have.
I don't care. They've been around since Euclid. Let's have them. I mean, they're not going anywhere. The midpoint is not. It's a concept that is a well understood concept. It's a word in mathematical language that's been around for a couple of thousand years. I think we should have it. Is there any objection to that? I don't think having an extra 20 such words lying around is a problem because these words, they're not going anyplace.
Right.
And even something like a triangle foot. I mean, I don't really see a problem in having that. It's a little weird, but the foot of the altitude. Well, I don't know what the altitude is. That's kind of weird.
Yeah,
I mean, okay, so there are ones of these that might need to be tightened up a bit, but I think
does that assume a particular orientation of the triangle?
Yes, it's kind of crazy.
No, I don't think it does. You project A onto the line BC.
Right. So if you look at the argument, it's
scroll down and there's examples.
Right. A is separated from B and C.
Yeah, this is a footed triangle, so to speak. What the heck is it?
No, it's a foot. It's a point.
Oh, I see.
Footed.
Well, wait a minute. What is the point is, I see, the point is the projection of that guy. If the thing formed a triangle, it is, wait, a minute. I don't know.
I think your train of thought there was correct.
What's that?
I should have put in a graphic to illustrate this, but what you were just saying, I think you have the idea.
Oh, it's a projection.
Mm-hmm.
Right.
Yeah.
And then there's triangle altitude somewhere, which is just connects the vertex to the triangle foot, and it returns a line.
I think we should have these things. I really don't think there's any harm in having, well, this one I'm a little less.
Yeah, there are more, Stephen. You might want to open the cells on the right. You missed some.
What? Oh my gosh. Okay, look, some of these, like quadrilateral, would have to be supported quite generally.
But quadrilateral is so often occurring, I think we should have
No,
it.
fine. But then Roger needs to support it in the region system. I don't think that's okay. Clockwise, I'm not at all convinced about.
Now we come into more interesting ones.
Ugh. Well, some of these seem reasonable. So you can have an equilateral pentagon and things as well, presumably.
Yes.
So, I mean, there's some parts of speech issues here. Okay, so, I mean, one question is, I mean, if I were to look back at Euclid, would I find mutually tangent as a predicate there?
Probably not, but you would find it in like 18th century geometry and onward.
Okay. So 200 years, but not 2,000 years. Why is it not congruent and similar? Congruent region.
So there's a stronger notion of congruency that only applies to polygons. It says that corresponding vertices get mapped to each other.
Okay.
And for implementation purposes, that's the only one we could support.
Mm-hmm.
Okay.
And only in 2D.
I would expect region congruent or whatever it to be called to just want there to be a rigid motion that takes one to the other.
Okay.
I have to click on the right side. Yeah.
So angle would evaluate if it's given explicit points, yes?
Yes.
Don't we already have a function that does that?
We have vector angle.
Vector angle, yeah.
That's a 2-arg function, right?
Right.
And this is a 3-argument function.
Correct.
Okay. Boy, what's that? Whoever's talking is only just a few bits are left. Hello? There.
I think it was Roger.
Sorry, I had a power fluctuation. I'm sorry, I'm going to mute.
Radius is certainly, that seems very problematic to have a thing actually called radius here. I'm sure that we can decorate these names to make them more reasonable. Oh boy, okay, we're really running out of time here. Yeah. We're way over time. But this is, I mean, okay.
Did we have another meeting?
We need another meeting, yes. This is really cool, though. It's really cool, all this stuff. But I mean, only their angle measure. Oh my gosh. Okay. Let me take a look at this. Many polygon descriptors. Yeah. I mean, maybe things like this. I don't know. I mean, another question is what the natural language, how are we going to do it? If, presumably we will have a natural language to this stuff translator.
Definitely we want it. We have not started any form working on it.
Okay. It doesn't seem super duper difficult. Or am I missing something?
A lot of the problem is there's implicitly there are things that are implied that aren't explicitly stated.
Yeah, but that's what we can deal with algorithmically, right? I mean, all we're trying to do is to generate one of these geometric scene representations, and if there are things that are not specified there, that's what you'll find geometric scene instance is supposed to deal with. Am I mistaken?
What he means is that like problem statements in books will leave out necessary assumptions because
how necessary?
Lack of rigor, like absolutely necessary.
There's an example in this notebook.
Control F for Finsler.
Yeah, Control F Finsler. Yeah, orientation of polygons. It's under there.
What's that?
I said orientations of polygons. You're right, that top one. So Finsler-Heidegger theorem. So even in let's see, so these aren't
oben that says.
Yeah. Right. So the conclusion is that circle or that square, that rectangle in the middle, STQR, is supposed to be a square, but here it's not, because the square A, B prime, C prime, D prime is supposed to have the same orientation as the square A, B, C, D, but it's not specified. And if you look in Wikipedia or Math World, it's not specified. You just, looking at the picture, they have the same orientation, but it's never actually said anywhere.
But if we wrote the proposition that thing PQ, QRST is a square, that proposition could still be validated given that scene. Is that true? That there exists a way to make that a square?
Well, no, the statement is...
It's always a square.
Right. Well, yeah, the statement is it's always a square, and this is a counterexample to the normal statement where people leave out that A, B, C, D, and A, B prime, C prime, D prime have to be oriented the same way.
So how on earth would one fill that in?
Right. This is why we brought it up with processing natural language. We're going to have to deal with the fact that a lot of times...
processing any input at all. I mean, so somebody might give the conditions for this thing. They might put them in Wolfram Language, and they'll still get the wrong answer.
Right.
I mean, they'll still... Okay, so what is the actual dynamic? So somebody is doing a geometry exercise, and they're asked this question, and... yeah, I mean...
We were thinking to a limited amount, basically, if we have such potential orientation issue, trying both and giving messages.
Right.
Okay.
So yeah, one thing...
Is this the most common form of dropped assumption?
Yes.
There's one other where you list lines as parallel, but they need to be oriented the same way in the same direction as opposed to anti-parallel, and that's kind of a dropped assumption too.
Okay, but those are both combinatorially enumerable.
Right. And also both of those are solved by the counterclockwise and clockwise symbols that we proposed.
Okay. I mean, as a way to disambiguate them.
Correct.
But in terms of... I see. I mean, in terms of user behavior, if there's a finite number of possibilities and you can just enumerate them and look at the different cases, that's okay. That would be pretty reasonable. Okay. I'm really out of time here, but I'm enthusiastic to see different things. Okay, so that's a quadrilateral, fine. What's your point here? That those are different numbers of angles. Those are different angles.
Right. So there's the...
and they really work.
Yeah, these you can evaluate if you want. This one here is probably somewhat slow, but it's a little more complicated.
I still want to understand how to speed these up. I want to understand what there's got to be some way to, effectively interpolate these. Maybe I'm crazy. I mean, maybe it seems like there's something very special about the surfaces that correspond to the things you're trying to optimize over here. But maybe it's not special. I don't know. I mean, do you have a characterization of what's special about the optimization problems that you're doing here, as opposed to generic optimization problems?
They're not entirely polynomial. I'm not sure there's really anything. So these are yeah.
So what's the point of these?
So they're just supposed to be.
It's kind of unfortunate they're on top of each other. I mean, there's two congruent triangles. Again, that should be part of the the drawing optimization layer. This is really quite spectacular, though. I mean, it's very cool functionality.
I just want to point out that these examples all work because they're using an older version of the scene language.
Right. Here we're using the old geometric point. It works both ways. Johnson's theorem is pretty slow because it has a bunch of very interconnected circles. Some of these advanced geometry ones do take a while because the more complicated the scene is and the more
So wait a minute. So this particular thing has not broken the proposition from the. Is this because it's an older version?
This is just an older version.
So the proposition is sitting along with the other stuff.
Mm-hmm.
Right. So here, these are just the hypotheses. And that's actually an accurate picture.
Wow. Cool.
Yeah.
Okay. Napoleon's theorem.
Yeah. I feel like Napoleon didn't actually do this himself.
Are you sure?
This is another one that the output on this particular theorem. Well, right. So you see a lot of extra lines because it involves centroids, and currently for triangles, the centroid, if you drop these altitudes, they all meet in the centroid. So I draw the lines, but now that I look at it, it's a little confusing to actually draw
Well,
those.
let me just make them dotted lines or something.
Yeah.
All right, spectacular functionality, guys. Clearly, we need to have a further discussion about it, but I think this
so
looks
overall,
like...
you're fine with geometric scene, head, first argument points, and inside style of something.
That's what I'm fine with, and I'm also fine with the idea of introducing, anything Euclid did is okay. 200 years ago, it's still okay. Any of those kinds of geometric predicates seem fine to me. Some of them may need a little bit more detailed names.
So new stuff, even if from Arnold from 10 years ago, no.
Like what?
He introduced a couple generic region centers. That fulfill
the question of lots of region centers, that's probably a string name for the region centers. And then, you can go to town and put in any region center you want.
We are actually thinking on putting the 15,000 triangle centers in this way rather than adding 15,000 symbols.
That's exactly.
What do you mean? What do you mean 15,000 triangle centers?
There's a website.
15,000 named triangle centers.
Right. There's a website where this one guy compiles all of them. There are.
I'm sure there's a lot of those that have put up jobs. I cannot imagine there are 15,000 sensibly named ones. Why would somebody? Well, I won't even go there.
Publish or perish.
Okay, fair enough. This is really cool functionality. Very nice stuff. Look forward to seeing more of it.
Okay, thanks.
Thanks, guys, and bye to everybody on the live stream. Thank you for your participation.